In this video, we're going to be doing some parametric function practice problems. So for problem 1, a particle moves along the curve defined by the rectangular equation x is equal to 9 minus y squared. Find the parametric equations for each situation. A. The particle starts at 0, -3, moves upward, and reaches 9, 0 when t is equal to 3. So we're going to start from x is equal to 9 minus y squared for part A. So we're going to let y equal to our parameter. If we want the particle to start at 0, -3, we can plug in y is equal to -3. As you can see here, -3 would be your y. So then you would get 9 minus 9 is equal to 0. Therefore, our starting point is valid. It starts here, it moves up, and it reaches 9, 0 when t is equal to 3. That means that we want y is equal to -3 at t is equal to 0. And we also want y is equal to 0 at t is equal to 3. This was y is equal to -3 at t is equal to 0. So now we're going to do x minus is equal to 9 minus t minus 3 squared. So our equations are going to be x is equal to 9 minus t minus 3 squared. Y is equal to t minus 3. Now for part B, the particle is going to start at 5, 2, and it moves downward and moves twice as fast as in part A. So we can check that point on the curve, 5, 2, and see if it lies on the curve. So x is equal to 9 minus y squared. Now you plug in your y. So you have 9 minus 2 squared. 9 minus 4 is equal to 5. So we can see that it moves down. So y must decrease as t increases. In part A, we saw that y is equal to t minus 3. So that means that the rate of change of y with respect to t is equal to 1, aka your m is equal to 1, your slope. So that means that here you can say x is equal to 9 minus 2 minus 2t squared. X is equal to 9 minus 2 minus 2t squared. Y is equal to 2 minus 2t. Now, for part C, using your answer from part A, determine the points on the curve when t is equal to 0, 1, 2, and 3. Describe the direction of motion. So using part A, C, we're going to start with x is equal to 9 minus t minus 3 squared, and y is equal to t minus 3. Now we're going to sub in our values. So when t is equal to 0, we're going to substitute in. So this is just going to be substituting in 0 for all those locations. So these are our points. So because we see that y is going to increase when we go from -3 to 0, that means the motion is upward along the right opening parabola. You can see that it's a parabola because you have only one variable squared. A curve is defined parametrically by x is equal to 4 cosine t plus 1, y is equal to 2 sine t minus 3, for 0 is less than or equal to t is less than or equal to pi. Find the rectangular equation of the curve. So, we're going to solve for cosine t and sine t. So cosine t is equal to x minus 1 divided by 4. Now here, y plus 3 is equal to sine t. This is actually 2 sine t. So we have 2 sine t. And sine t is equal to y plus 3 over 2. Now, you can use sine squared t plus cosine squared t is equal to 1. And substituting, that's x minus 1 over 4 squared plus y plus 3 over 2 squared is equal to 1. So now you can square everything in the top, the bottom, and here. So we can see that this is an ellipse because each of the terms, they have a positive symbol sign in front of it, and we can see that if you ignore just what is that sign and you can take that negative sign out, here we can see that our HK center is going to be 1, -3. Now, what is the domain and range of this? And what's the starting point, ending point, direction of motion as t increases, and also whether this graph represents the entire conic or only part of it. So for domain and range, we know that your A is going to be equal to the following. So here we know that this is going to be a squared, this is going to be b squared. So A is going to equal to 4 and b is equal to 2. So that means that a full ellipse would have the domain and range of the following. You would have x is the set of -3 to 5. Y is the set of -5 to -1. However, in this problem, we're given a domain restriction, which is this, and because of that, we must respect it. So we know that on this interval, sine t is going to be greater than or equal to 0. Because it can't be negative. Negative numbers are not included in this interval. So that means that it has to be greater than -3. And also, so that means that y has to be less than or equal to -1. That means that our range, for our actual range, is going to be -3 less than or equal to y less than or equal to -1. And for x, cosine t goes from 1 to -1 as t goes from 0 or to pi. So x is equal to 4 cosine t plus 1 is going to be from -3 less than or equal to x less than or equal to 5. Now we need our starting and our ending points. So you would do what your range is. So you would plug in to get your start point. You would go to the very maximum of your interval. So that would be your start. And then your end would be at your very end of your interval. So let's plug those in for t. Now, t is equal to 0. You have x is equal to 4 cosine. Now finally, let's find our direction of motion. We can be strategic with this and we can use our middle value, which here would be t is equal to pi over 2 as an example. So right now, as our points, here we have 1, -1. So that's in our ellipse. Let's actually graph that. So we're going to go one and then down 3. Now, A is going to be under your X, so that is your horizontal. And then this is your vertical. So we're going to go wide 1, 2, 3, 4. So we're going to go this way. 1, 2, 3, 4. And up we're going to go 2. So it's 1, 2, 3, 4. Actually over 1, so. And then here you're going to go down 2. Now, our points go from 5, -3 to 1, -1 to -3, -3. So that means you're going from the top half right to left. other way, right to left. So that means it's going to be counterclockwise motion. So our answer is going to be the top half of the ellipse. Top half of ellipse. It's not going to be the full conic. So we can actually cut off everything here. It's right to left. Right to left. Now, for this question, a particle moves in a straight line and passes through the points 4, negative 4, 7 at t is equal to 1 and 8, negative 2 at t is equal to 4. Parametric equations. Find parametric equations x of t and y of t for the motion. The speed of the particle and the position of the particle at time is equal to t is 2. And the time when the particle crosses the y-axis. So, we know we have to find the change in these two coordinates that we were given. So, change in x is going to be 8 minus negative 4. And change in y is negative 2 minus 7. So, change in time is equal to 4 minus 1. As you can see here. So our rates here are going to be so we have x is equal to 4t plus b, y is equal to negative 3t plus c. Now if we use t is equal to 1, we know that since the particle at t is equal to 1 is negative 4, 7, given in the problem, we can sub this in to get x and y equations. 4 times 1 plus b, negative 4 is equal to 4 plus b, b is equal to negative 8. So that means we have x is equal to 4t minus 8. We have 7 is equal for y. This is for x. 7 is equal to negative 3 times 1 plus c. 7 is equal to negative 3 plus c. C is equal to 10. So y is equal to negative 3t plus 10. So those are our parametric equations. How do we find speed? So that was for part A. For part B, to find speed, we have to take the root. So we have dx over dt squared plus dy over dt squared. So your speed is equal to the root of 4 squared plus negative 3 squared. That's going to equal to 16 plus 9 equal to the root of 25 is equal to 5. Now, what about at position equal to t of 2? And what time the particle crosses the y-axis? So for C, you're going to set t is equal to 2, and you just plug in to get your x and y. 8 minus 8 is equal to 0, and y is equal to negative 3. 2 plus 10, and that's equal to negative 6 plus 10. That's equal to 4. And that's going to be 0, 4. Now, when does it cross the y-axis? So what does it mean when you cross the y-axis? That means that x is equal to 0. So x is equal to 4t minus 8. 0 is equal to 4t minus 8. 4t is equal to 8. And t is equal to 2. And that point was 0, 4. 0.04. Now, a Ferris wheel has a radius of 18 and its center is 20 feet above the ground. At time t is equal to 0, a rider is at the leftmost point of the wheel. The wheel rotates clockwise and completes one full revolution every 24 seconds. Find parametric equations describing the rider's position, the rider's height after 6 seconds, the first time the rider reaches the top of the wheel, and the horizontal and vertical coordinates of the rider after 15 seconds. So when you have a circle and a center, that's going to be hk, x is going to be h plus r cosine theta, y is equal to k plus r sine of theta. Here our h is equal to 0, our height is equal to 0 because it's on the ground, our k is equal to 20 because it's 20 feet above the ground, and our r is equal to 18. So that means that if you sub those in here our h is this and our k is this and our r is that. So our new forms are going to be like this. You're going to have x is 18 cosine theta, and you're going to have y is equal to 20 plus 18 sine of theta. Now we need to get our starting point. And when t is equal to 0, your rider is at leftmost point. So when we have t is equal to 0, we have to find these equations. We know cosine pi is equal to -1 and sine pi is equal to 0 on the unit circle at pi. And one way to use that angle is theta is equal to pi when t is equal to 0. So we're going to get the angular speed. So omega is equal to 2 pi over t, which is equal to 2 pi over your period. So here it's 2 pi over 24 because one revolution is equal to every 24 seconds. So that goes there. And this is 1 rev. And this is aka your time. So this is equal to 2 pi over 24. That's equal to pi over 12. And the wheel is going to rotate clockwise. So your angle decreases as time increases. So it rotates clockwise. That means you're going this way. Now, theta is going to equal to pi minus pi over 12t. So now we have our theta, right? Now you can take let's take this t. This is t. So you can take this expression and you can sub it in for these here, or no, you can sub that in here and here. So let's just rewrite these with theta subbed in. So you're going to have x is equal to 18 cosine pi minus pi over 12 and times t. And you have y is equal to 20 plus 18 sine pi minus pi over 12 t. Now, after this, we need our height after 6 seconds. So this is part B. Now, our h after 6 seconds. So y is what we're going to have to find, your y coordinate, which is your height. So 20 plus 18 sine pi minus pi over 12. Instead of t, we're going to put 6, and we just simplify now. So it's going to be 38 feet. And we want, when does the rider reach the top of the wheel? So at the top of the wheel, top of your wheel, you're going to have y is equal to 20 plus 18, 38. And this happens when you have sine pi minus pi over 12t that's equal to 1. So you have pi minus pi over 12, t is equal to pi over 2. And you just have to solve this now. So you're going to have plus. So you have pi over 12 is equal to pi over 12. And you have, canceling out that pi, you have 1 over 12 is equal to, oh wait, so you have t here. You have pi minus 12, this is 12 actually. And this is t, so that's pi over 2 is equal to pi over 12. T, you have 1/2 is equal to t over 12. So t is just equal to 6 seconds. So that is the first time at top of wheel. Now, what are your coordinates? What is your x, y, post 15 seconds? Now, you just substitute t is equal to 15. X coordinate will be 18 cosine pi minus pi over 12 pi, or 15. This is 15. Now, this is 18 cosine pi minus 15 pi over 12. 18 cosine pi minus 5 pi over 4. 18 cosine negative pi over 4. 18 root over 2 over 2. 9 over the root of 2. For y, that's equal to 20 plus 18 sine pi minus 15 pi over 12. This is 20 plus 18 sine negative pi over 4. This is 20 plus 18 negative root 2 over 2. And this is 20 minus 9 over the root of 2. So that means our coordinate pair is 9 root 2, 20 minus 9 root 2. So that's your answer for where this rider will be at 15 seconds.